Hi everyone. So today's lesson on valences. So we have valence electrons. Valence electrons are the outermost electrons on an element, and really easy. Take a look at the Lewis dot diagram and count the number of dots or X's or whatever other symbol you use for the electrons. And that number for valence electrons will be anywhere from 1 to 8. Okay? Let's go with valence. Valence is the element's bonding capacity. Now think about it. An element will form either an ionic or a covalent bond. So it forms an ionic bond. It'll be the number of electrons that the element will either lose if it's a metal or gain if it's a nonmetal. And if it's a nonmetal, then it's going to form a covalent bond, right, with another nonmetal, and it would be the number of electrons that it shares. So the real easy way to do valence is count the number of single electrons around the Lewis dot diagram. If you do that, you're going to get it right 99% of the time. And I'll show you some of the exceptions at the end of this video. For electrovalence, it's the element's ionic bonding capacity. So that's the number of elements that it'll either lose or gain, depending if it's a metal or nonmetal. And for that, again, you're going to count the number of single electrons. Now, here's the key. If it's a metal, you're going to give the electrovalence a positive number. And if it's a nonmetal, you're going to give the electrovalence a negative number. Okay? That's the only one that's going to have a positive or a negative number. If we're dealing with a covalence, again, it's the element's single electrons on the Lewis dot diagram. It's not going to have a positive or negative. And remember, metals don't form covalent bonds. So they are not going to have a covalence. So you need to put a Na for not available or a slash through it or something like that. Don't leave it blank, because blank just basically means you didn't know. Okay? We're going to watch a video now, and I'll show you some of the exceptions.
Hi everyone. I'm just going to show you some of the exceptions to your homework. So this is nitrogen, and if we count the number of dots around the Lewis dot diagram, we're going to get the number of valence electrons, which in this case is 5. Now for valence, remember we count the number of single electrons. So we have 1, 2, 3. So it would have a valence of 3, an electrovalence, and a covalence of all of 3. Now, nitrogen is a nonmetal, so the electrovalence has to either have a positive sign if it's a metal or a negative sign if it's a nonmetal. So I just have to make that -3, which tells me that it would gain 3 extra electrons. Okay? Now, here's the exception part of it. What nitrogen can do is nitrogen can take this pair of electrons up here and separate it. When it does that, nitrogen would kind of look like this. So, when it looks like this, if we count the number of single electrons, we have 5, right? Still 5 valence electrons, but now it would have a valence of 5. Okay? And this exception, it will not gain an extra 5 electrons, so it doesn't apply to an electrovalence. However, when it's like this, it could share all 5 of these electrons. So that would give you a covalence of 5 as well. Couple of things. We never, ever, 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 ever draw nitrogen like that. So if I ask for the Lewis dot diagram of a nitrogen atom, don't ever draw it like that. Okay? You're always going to draw it like this. Now, these exceptions make it interesting, and this is where the octet rule doesn't fall into place all the time. If you draw it like this, nitrogen will have, after it's done sharing or gaining electrons, it will have 8 electrons around its outer shell. When nitrogen does this, the exception, right, if all 5 of these electrons were shared, what would you have? You would have 10 electrons around it. And that kind of goes against the octet rule. So that's why I said the octet rule is fine, what you learned in grade 10, but there's too many exceptions to really think of bonding only to get 8 outer electrons. That's why it's better to just look at it as being a matchmaker. Okay? Here's the other exception, and this exception is sulfur. So this is sulfur the way we would normally draw it, right? So it has 1, 2, 3, 4, 5, 6 valence electrons. Valence, count the single electrons, 1, 2. And again, electrovalence has to either have a positive or a negative sign, and sulfur is a nonmetal, so it has to be a negative sign. It's that easy assigning them, okay? Now, here comes the exception. The exception for this is sulfur has the ability to take this pair of electrons and separate them. So when that happens, you do this. How many single electrons do you see? 1, 2, 3, 4. So it would have a valence of 4. Doesn't affect the electrovalence and could share those 4 electrons. All right. Sulfur can also separate both pairs. It does that. It now has 6 single electrons around it. Doesn't affect the electrovalence. And those 6 single electrons would be shared, which would change and give you an exception for the electrovalence. Again, when we draw sulfur, we don't ever actually draw it like those. You're always going to draw your Lewis dot diagram like this one. Okay? Are these the only 2 elements that have the exceptions? No. So listen very carefully. For sulfur, sulfur on down in that same family will do that. And if we go back and we look at the nitrogen and all the elements in the same family will all do the same thing as this one. Okay? I hope that helps. Take care.